Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I would love to learn more about the use of knowledge distillation in training language models, specifically in the context of Hugging Face's Zephyr 7B beta. Could you please explain how knowledge distillation works and how it was applied to train the Zephyr 7B model?
Of course. Knowledge distillation is a technique used to train smaller language models by leveraging the knowledge of larger models. In the case of Hugging Face's Zephyr 7B beta, knowledge distillation was used to train the model using a larger model called Mistral 7B. Now, let me explain how knowledge distillation works using a simple metaphor. Imagine you have a very knowledgeable teacher, the larger model, and a student, the smaller model. The goal is to make the student just as knowledgeable as the teacher. In knowledge distillation, the teacher model is first trained on a large dataset of human-written texts. This allows the teacher to learn a wide range of language patterns and understand how humans write. Next, the student model is trained using a process called Distilled Supervised Fine-Tuning, DSFT. This involves two steps. First, the student model is trained on instruction datasets generated by the larger models. These instruction datasets consist of questions or instructions paired with answers provided by the larger model. Then, the student model's outputs are compared and ranked against the outputs of the larger models using a state-of-the-art language model. This helps to align the student model's answers with human preferences. Finally, the student model is further trained using a technique called Distilled Direct Preference Optimization, dDPO, using the data obtained in the previous step. This helps to refine and improve the student model's performance. So, in summary, knowledge distillation involves training a smaller model, Zephyr 7B beta, by distilling the knowledge from a larger model, Mistral 7B. This allows the smaller model to learn from the larger model's expertise and perform at a similar level, while being more affordable and easier to train.
That's a great explanation of knowledge distillation and how it was applied to train the Zephyr 7B model using the Mistral 7B model. I'm curious about the datasets used in this process. Could you please elaborate on the datasets generated by other models and how they were used for training and ranking the Zephyr 7B model's responses?
For training and ranking the Zephyr 7B model's responses, instruction datasets generated by other larger language models, LMS, were used. These instruction datasets contain pairs of instructions, questions, and their corresponding answers provided by humans. However, collecting such datasets is expensive and requires significant human labor. To overcome this challenge, a common and cost-effective alternative is to use instruction datasets generated by other LLMs. In the case of Zephyr 7B beta, Hugging Face fine-tuned Mistral 7B, which is a larger model, on a custom version of UltraCat. UltraCat is an LM that generates instruction datasets. The first step in training Zephyr 7B is supervised fine-tuning, SFT, on these generated instruction datasets. During SFT, Zephyr 7B learns to generate responses by observing the instructions and corresponding answers provided in the dataset. This helps Zephyr 7B understand the patterns and structures of human-generated responses. After SFT, the next step involves scoring and ranking the outputs of different LMs, including Zephyr 7B, using a state-of-the-art LM data. This ranking process helps identify the quality and relevance of the responses generated by Zephyr 7B compared to other models. It serves as a benchmark to evaluate Zephyr 7B's performance in various domains, such as writing, roleplay, reasoning, math, coding, extraction, STEM, and humanities. Overall, the combination of training Zephyr 7B on instruction datasets generated by other models and ranking its responses using a state-of-the-art LM contributes to enhancing the performance and capability of Zephyr 7B.
Thank you for explaining the use of instruction datasets generated by other LMs and how they were used for training and ranking the Zephyr 7B model's responses. This approach seems to provide a cost-effective way to leverage existing datasets and evaluate the performance of Zephyr 7B across various domains. Now, I'm curious about the evaluation of Zephyr 7B beta. Can you please share some insights into how its performance compares to other language models? Were there any notable findings or achievements in the evaluation process?
According to the report, Zephyr 7B beta performs better than Llama 270B and is on par with other state-of-the-art commercial language models in various tasks, such as writing, roleplay, reasoning, math, coding, extraction, STEM, and humanity. However, it is mentioned that Zephyr's main teacher, GPT-4, still outperforms Zephyr in tasks related to reasoning, math, coding, and extraction. In terms of the evaluation process, the report mentions that an ablation study was conducted to demonstrate the importance of direct preference optimization, DPO. The study found that DPO alone performs poorly, but when combined with CFT, soft fine-tuning, it outperforms CEFT alone. This shows the effectiveness of DPO in improving the performance of Zephyr 7B.
Thank you for providing insights into the evaluation of Zephyr 7B beta. It's interesting to note that Zephyr 7B beta performs well compared to Llama 270B and other state-of-the-art commercial language models in various tasks. However, there is still room for improvement in tasks related to reasoning, math, coding, and extraction, where Zephyr's main teacher, GPT-4, outperforms it. The ablation study conducted to evaluate the effectiveness of direct preference optimization, DPO, in combination with soft fine-tuning, CFT, is also noteworthy. It demonstrates that DPO plays a crucial role in enhancing the performance of Zephyr 7B beta, outperforming SFT alone. This highlights the importance of incorporating DPO into the training process to achieve better results. Overall, the evaluation of Zephyr 7B beta showcases its competitive performance among other language models in various domains, and the significance of incorporating DPO for improved performance.
According to the evaluation on MT Bench, Zephyr 7B beta performs closely to other state-of-the-art commercial language models, LMS, in various tasks such as writing, roleplay, reasoning, math, coding, extraction, STEM, and human. It outperforms Llama 270B, another LMM, and remains competitive with larger models like GPT-4 in most areas. However, it's important to note that GPT-4, which is Zephyr's main teacher, still performs better than Zephyr in reasoning, math, coding, and extraction. So while Zephyr is impressive in its performance, there is still room for improvement in these specific areas.
Yes, you're absolutely right. The evaluation on MT Bench indicates that Zephyr 7B beta performs closely to other state-of-the-art commercial language models, LMNs, in a wide range of tasks, including writing, roleplay, reasoning, math, coding, reasoning, math, coding, extraction, STEM, and humanities. It's commendable that Zephyr 7B beta outperforms Llama 270B and remains competitive with larger models like GPT-4 in most areas. However, it's important to acknowledge that GPT-4, which serves as Zephyr's main teacher, still outperforms Zephyr in specific domains such as reasoning, math, coding, and extraction. This highlights that there is still room for improvement in these particular areas for Zephyr 7B beta. Overall, Zephyr 7B beta's performance is impressive, but there are ongoing efforts to further enhance its capabilities. especially in domains where its performance can be further optimized.